For section 8.3, we're going to use our information, our trig functions to solve right triangles. So we're going to jump right into an example here, and it says use the trigonometric ratio, the cosine of A equals 0.6 to determine which angle of the triangle is angle A. So they're labeled angle 1 and angle 2 here, and we need to figure out when we do the cosine of that angle, when do we get 0.6 as an answer? So if you remember from yesterday, the cosine, remember the SOHCAHTOA, the cosine is the CA, which is the CAH. So it is adjacent over hypotenuse. So if I start here with angle 2, opposite, sorry, not opposite, adjacent would be right here, the leg that's attached to it, which would be 4.8. And then over hypotenuse, the hypotenuse is the longest side across from the 90-degree angle, which in this case is 6. And then I test that out, and this is for angle 2. 4.8 divided by 6, and when I do that, I get 0.8. I'm looking for when do I get 0.6. So now we have to do the same thing, but do this with angle 1. So angle 1, if I did adjacent to angle 1, that would be this line here. So that would be 3.6 over the hypotenuse, which is 6. And then type in your calculator 3.6 divided by 6, and that does give you 0.6. So which triangle is, or which angle is angle A? Angle 1 is angle A, because that's where when we took the cosine of that, we got 0.6 for our answer. So it's kind of like a guess and check. All right, now, if you know the sine, cosine, and tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measure of the angle. So if we know the sine of angle A is x, then we take the inverse sine of x, and that will give us the measure of the angle. And then again, if we know that the cosine of angle A is x, if we take the inverse cosine of x, we will get the angle measure. So if we know the sine, cosine, or tangent, if we take the inverse of that number, it will give us the measure of the angle. So first off, we're going to start by just using our calculator and typing in the inverse cosine of 0.5. And on our graphing calculators, that is right above cosine. You'll see cosine -1, so you have second and then cosine button, and 0.5, and then hit enter. And when we do that, we get an answer of 60. And then the inverse sine of 0.45, nearest degree, we get 26.7 when we round or put it in our calculator. So rounded to the nearest whole is 27. And then the inverse tangent of 3.2, we get 72.6. So 72.6 rounds to 73. And these are degrees because these are helping us find the angle measures that are missing. If we know the sine, cosine, and tangent, we can work backwards and figure out the angle measures. So using given measures to find the unknown angle measures or side lengths of a triangle is known as solving a triangle. So to solve a right triangle, we need to know two side lengths or one side length and an acute angle measure. So we have to have two pieces of information, either two sides or one side and one angle. So example 3, we need to find the unknown measures and round lengths to the nearest hundredth and angle measures to the nearest degree. So the first thing that I am going to do is write SOHCAHTOA down. And then we can use that because we know two side lengths, we can figure out some angle measures using this information. So if we look at angle C here, we know the adjacent and we know the opposite. So opposite and adjacent is the tangent. It's the TOA part. So the tangent of angle C is the opposite side, which is 7.5, over the adjacent, which is 5. So if I solve that out, the tangent of C equals 1.5. Now I want to know what C is, so what I'm going to do is take the inverse tangent of 1.5, and that is going to give me the angle measure of C. And that is 56.3, and they asked us to round to the nearest degree, so that would be 56 degrees. So the measure of angle C is 56. So I'm going to erase this stuff. Then, looking at the angles in the inside, I can figure out the third angle because this over here is 90. So I would have to do 90 plus 56 is 146, and then 180 minus 146 is 34. So this other angle is 34. Now, to figure out the hypotenuse, we can do a couple of things. We can use the Pythagorean theorem. And remember, the hypotenuse is the C. So we can do 5 squared plus 7.5 squared is going to give us our C squared. So that's 25 plus 56.25 would give us C squared. And then if I add those together, I get 81.25. Then I have to take the square root of 81.25. And I get 9.01. And it says round the links to the nearest hundredth. So this would be 9.01. And then now we have all side links are given and all angles are given. Now, if you didn't want to use the Pythagorean theorem to find the hypotenuse, we can pretend like we don't know this 9.01 right now. And the hypotenuse is included in the sine and the cosine. So if I worked with the sine, remember the sine of, let's say C is 56, so the sine of 56 equals its opposite side, which is 7.5, over the hypotenuse. So this is where I would flip these. So I would have x equals 7.5 over the sine of 56. And when I type that in my calculator, 7.5 divided by the sine of 56, I get 9.04. Now, the reason that happened is because if you remember, we had to round this tangent, the inverse tangent of 1.5, where I have it is equal to 56 right here. We rounded that, so it wasn't exact. So when I used 56 here, I didn't get 9.01 exactly because we rounded that 56. So if you see how close that is okay. So we still know it is right in that area somewhere. I would not mark it wrong if you had 9.04. So a couple of different ways to figure it all out. So you can use the trig functions mixed with some Pythagorean theorem, or you can use all trig functions. So it's up to you, whatever is easier. And then for our last example here, we have the coordinates of the triangle JKL given, and I graphed it already for us. And we need to find the side lengths to the nearest hundredth and angle measures to the nearest degree. So again, we're going to use that SOHCAHTOA So we can figure out side lengths on the two sides just by counting. So from 2 down to -3, that would be a 5. And then from -1 over to 3, that would be a 4. So we have that, and we also see that this is a 90-degree angle. So if I picked angle L here to work with, I would have opposite and I would have adjacent. So opposite and adjacent are the tangent. So the tangent of angle L is opposite, which would be 5, over adjacent, which would be 4. And so the tangent of L, 5 divided by 4, is 1.25. Now to figure out what L is, I take the inverse tangent of 1.25. That's doing the opposite. So inverse tangent of 1.25 is 51.34, and they wanted this rounded to the nearest degree, so that would be 51 degrees. So angle L, goodness, undo. Angle L is 51, and then we know that K is 90, so 90 plus 51 is 141, and then we do 180 minus 141 gives us 39. So this other angle is then 39. So now we just have the hypotenuse left to figure out, and when I do that, maybe I'm going to look at angle J now. So I'm going to start here, and we want to find that hypotenuse. So we definitely want to use the hypotenuse. We have opposite here, and the hypotenuse is what we're missing, what we need to figure out. So opposite and hypotenuse would be the sine. So the sine of 39 is opposite over hypotenuse. So 4 over x, and then this is where the x is at the bottom, so we're going to flip those two. So we're going to have x equals 4 over the sine of 39, and the 4 over sine of 39 is 6.36. So this side length, because they wanted us to round side lengths to the nearest hundredth, is 6.36.